Hey, this is Mr. Aiden, and this is AP Physics C, Background Skills, Unit 0, Part 2, and we're going to be taking a look at a lot of the calculus today that you're going to be facing all years, how to find a derivative, how to find an integral. So let's get to it. You can see here we have a position time graph, which means we have a function, okay, and I'm going to designate this small circle as a function. The position, the x, is a function of the time. The dependent variable, the y value, is a function of the x, or the independent variable. And so what I want to find is, how is this position changing with respect to time? Okay, and what that means is I'm going to find its rate of change, or its slope in some sense, which we call a derivative. So this finding the slope, or this rate of change, is called a derivative. That's basically what it means. And we're going to find the derivative of that function, which in this case, the derivative of a position time function, is its velocity. Okay, so let me give you some examples of how to find derivatives. Okay, so we understand the power rule here. You can see we have a function 5x squared plus 3x plus 2 over x plus 7. Okay, so if I want to find his derivative, I'm going to take that power, okay, and I'm going to multiply the power, that 2, out in front. So 2 times 5 is 10, and that power will go down 1, so it'll become x to the first power. You can see this next value here, this plus 3x, that's really 3x to the first power. So we're going to do the power rule again. We multiply 1 times 3, that's 3. And that x goes down 1, which means he kind of disappears. Okay. Hope you see this third term right here, which is really 2x to the negative 1. I'm going to make it a little bit simpler. So now I'm going to multiply that negative 1 out front. So it's going to be negative 2x. And that negative 1 is going to go down 1 again and become negative 2, which means we could put that on the denominator with an x squared. And the derivative of any constant is just 0 because it is not changing its rate. Some other functions that you really want to know the derivatives of, obviously the derivative of a sine function is cosine of x. The derivative of a cosine function is negative sine of x. Okay. The derivative of e to the x is the simplest one. That is itself. It is e to the x. The derivative of a natural log function is going to be 1 over x. And then we also want to make sure we understand the chain rule. So here we have the function of sine of 3x squared. Okay, so to find the chain rule, the derivative of our sine of anything is cosine of 3x squared. Now we also have to take the derivative of the guy in the parentheses. That's the chain rule, which means we're going to multiply by the derivative of 3x squared, which means we're going to use the power rule. That 2 times 3 is 6. And that becomes x. So it's really, the derivative of this is 6x cosine of 3x squared. Okay. If you don't remember that stuff, then make sure you go in your book and practice some of those derivations. Now, we talked about the derivative being the slope. Going from the function to its derivative is taking the slope, or what we call the derivative. Well, to go the opposite way, we're going to take the area, or what we call the integral. Okay, the integral. And so that area, or integral, is the summation of all the parts. So if here you can see in this graph, I have a velocity time graph. Well, if I wanted to find how far, or the position, the displacement in which I've gone, I could take the area right here, this triangle, the area of this block, the area of that triangle, the negative area here, and the negative area here, add all those up, and that would be the distance, or sorry, the displacement in which I traveled. So you're going to want to be able to do some basic integrals. Okay, you can see this integral right here. What we're going to do when we find an integral is that power, instead of going down 1 like when we took the derivative, it's going to go up 1. so that 3 becomes a 4. And what do we put out front is 1/4, because if you can see, if you took the derivative of that, that 4 would multiply out front, cancel out, and would become x to the 3rd power. So the next one, we're going to make that x, he's going to go up to a 2, and you can see we're going to also divide or multiply by 1/2, which cancels out that 2. So we can leave it that. Plus 8, and we're going to put an x right there because any constant is just going to become 8x. Plus, remember, we could have a constant out front, so we have to include that c. Now, let's say we have something like this where we have inside our summation, our integral sign, we have a 3 and a 1, okay, which means we have a definite integral going on here. So what's the integral of 3? Would be 3x, okay? And we're going from 1 to 3, which means we're going to substitute in these. So 3 times 3 minus 3 times 1, which means 3 times 3 is 9, 9 minus 3, that equals 6, and that is the definite integral of that function right there. Okay? You want to know a few integrals. Remember, the derivative of cosine was negative sine, which means the integral of sine is negative cosine, because if you took the derivative of that, the antiderivative, the derivative of that, you would end up getting sine of x. Cosine of x is going to be equal to sine of x, because if you took the derivative of sine of x, you would equal cosine of x. And obviously, 1 over x, if you remember, was natural log of x, natural log of the absolute value of x. So that is just a quick run through of all of our derivatives, our calculus that we're going to use all year. You'll get better and better and better at it, but this was just a nice quick review.